have our equations. We have our increments filled in on our graph, right? So we're talking about these gym memberships. So where would I start the line for Jerry's gym? What is my y-intercept there?
At 10.
Yep, at 10. And then I have to go up $15 per month. So how many lines up will I actually go? 3. Why?
Because it's by 5.
It's by 5s, right? So you have to pay attention to those increments. 1, 2, 3. 1, 2, 3. 5, 10, 15. 5, 10, 15. All right. So that's Jim. Oh, that's Jerry's gym.
What the?
And then Frank's gym costs a little bit more up front, but $10 less each month. So there are some advantages there. So we'll start Frank's at $40, but I'm only going to go up $5 each month. And that happens to be one line. So when will they cost the same amount?
3 months.
3 months. How much will it cost?
$55.
Now, I'm going to be honest with you guys. I don't know how many of you either go to a workout facility now or you might want to in the future. It is not that cheap. It's just not.
My mom pays like 50.
50 a month, right? They're paying 5 and 15. So that's not realistic. I don't know why it's so expensive to stay healthy. That's why I walk my dog most days. Okay, so what's my solution for this equation? What's my solution? 355. If someone said, what's the solution of that linear system? You'd be like, well, this is where they cross, so it must be this point right here. Okay, when is it better to go to Jerry's gym? When is it? So before 3 months, yep, it would be $55. So before 3 months. When is Frank's Fitness Gym the better deal for you? After 3 months. If you want to go to the gym for 6 months, how much money will you save by joining Frank's Fitness Gym over Jerry's gym? So let's figure out how much it costs to go to Frank's for 6 months and how much it costs to go to Jerry's for 6 months. right, Mia, help me out.
Kind of say the answer.
Sure.
$30.
How'd you get that?
I went up. So for Jerry's
What are you going to do?
Mm-hmm.
like
So-
I hit 5.
Jerry's is at 100,
It's okay.
and Frank's is at 70. You will save $30. Fantastic.
What people are in
Funny, Mia?
Okay, I want you guys to do the hiking trail. Well, no, we'll do hiking trail together. This one's a little bit different.
But when you,
Did you need to see the last one again?
no, I was just gonna ask if you could give us a formula, but I think we can do it.
Well, this one's a little bit different. It's worded differently. It's not as like obvious. This one and the next one are not as obvious, but I might let you do the bird ones by yourself. Okay, everybody read this scenario about Kevin and John hiking, and then we will regroup.
Scenario.
Did you want to like do it?
I just want you to read it, get an idea of what's happening, and then we'll talk together because it's kind of a tricky one. All right, so tell me what's happening here. What are these guys doing?
Jogging.
And
Hiking.
yeah, one of them is kind of jogging on the trail. One of them's walking on the trail. I'm a little concerned about how slow Kevin's going, but that's fine. His choice. So we have John, who's starting at the beginning of the trail, 60 meters per minute. Kevin is 240 meters down the trail when John enters the trail. He's walking at 20 meters per minute. So we have to come up with our equations to represent this. So John is pretty easy. What would be the equation for him? He's just starting
60.
Yep. Y equals 60x, and you can put plus 0 if you want for the y-intercept. And then Kevin, how fast is he going?
20 meters.
And where is he when John starts?
240.
So that's what his y-intercept is going to be. Because they're starting at the same time. Kevin is already ahead of John, and then they're going to keep going at the same, right? So they're both going to eventually cross paths. John will eventually pass Kevin. That's what's going to happen here. So let's go ahead and do our increments. Our y-axis is going by 20-meter increments. All right, so let's go ahead and graph these. John is here at the beginning of the trail, And I need somebody besides Mia or Maddie to tell me how far do I go up and over?
60. 60 over 1.
Okay, but so how many lines do I actually go up?
1, 2, 3.
3, right? 20, 40, 60 over 1. Then for Kevin, we're going to start at 240. So he's significantly further, but he is in no hurry, right? So we're just going to go up 1 line over 1 for each 20-meter increment. All right. After how many minutes are John and Kevin at the same spot? How many minutes? I know you know, but I want someone else to. Rylan. 6. Right, because here's our solution right here. And how far are they on the trail?
360.
360 meters. So my solution is 6,360. So between what time increments, what minutes, is John still trying to catch up to Kevin? Rylan? Yeah, before 6.
Wait, what?
And then when then does Kevin now trying to catch back up to John? After 6 minutes. After 2 minutes, how far away are they from each other? So let's see, where is John at 2 minutes? And where is Kevin? Who said 160? How'd you get that?
I went to 120 and 280.
Good. So John is just at 120, Kevin is at 280. So 160 meters apart. Now, what if I wanted to know how far they were at 15 minutes? I can't do that.
Yeah.
So then I could go back to these equations. Where could I put the 15? Where?
Next to the 60.
Yeah, I would put the X stands for minutes, right? So I would just put the 15 here and figure out how far they are. Good job. Okay, next one. Oh, it was 160 meters apart. All right, so third period looked at me like I was crazy. How many of you have watched the show Full House? Like the old one. Like the old one. Okay, so am I crazy? And it's okay if I'm crazy. But wasn't there an episode where DJ had a math problem where she had to figure out how far apart 2 trains would be? Or when they would pass each other on the track? And then Joey kept trying to call like train stations, and they were like, we can't do your...
It had to do with like walnuts or something.
Did it?
Yeah.
Okay, but he called somebody, right? Okay, all right. I thought it was trains, but it was walnuts. Thank you, Emma, for clearing that up. I appreciate it. Okay, so in this scenario, we have train A and train B.
Are we finishing the whole packet today?
Nope.
Yes.
We're trying to figure out when will train A and train B pass each other on the railroad tracks. Okay? Brody and Ben. You guys okay back there?
Yeah.
You sure one of you doesn't need a new seat? All right. So train A is 750 miles away and traveling toward the city. Train B is leaving the city when train A was the 750 miles apart. So what we have here, look at the graph, look up at the screen for me. Train A is coming towards the city. Train B is going away from the city.
How they intersect.
So they're going to intersect, but the difference is that A is going to have what kind of slope?
That was not me, that was 90.
Which will give it what kind of number?
Negative.
Negative, okay? Because the y-axis is telling us the distance away from the city. So train A is going to be here. Train B is leaving the city. So that's where our intercepts are going to be, and they are going to crisscross, okay? So train A, how fast is train A going?
75.
So that's going to be my slope, but I need to have a negative there because they are going 75 miles closer to you at the city. So they're not going a negative 75 miles an hour. That's not a thing. They're just getting closer and closer to the city, so that it looks like a negative slope. Yep. And then they are starting 750 miles away. Train B is going away from the city, so that's going to be a positive slope. And they're just starting at the city, so they're at 0. Right? So it's going, and it looks negative because the train is coming closer to the city, but it's at a constant rate. So let's go ahead and fill in our increments. And then our distance increments are in increments of 50s. Okay, let's go ahead and graph the line for the train. Now, this one doesn't perfectly align with our increments. So we go down 75 over 1. So you just kind of have to estimate that it's going to be right here between 650 and 700, because that's where 675 would be. Down 75 over 1. Down 75 over 1. Down 75 over 1. So it's going to take that train 10 hours to get from wherever it is back to the city. That's a long time on a train. You guys ever been on a long train ride?
No, never been on a train.
Okay.
Wait. No.
It's not great.
It's so boring.
It's pretty boring.
I can't fall asleep on it.
It's hard to fall asleep because it like rattles. It doesn't rattle, but it's like not like being on a plane where it's smoother. Not great. Okay, train B is leaving at the same time train A started coming back to the city, and lucky enough it goes by 50 increments, so we're just going to go up 1 point each time. So we have train A and we have train B.
Why did you start at 0 for B?
Because B is leaving the city. So 0 is the city, right? So B is going away from the city. A is coming towards the city. So this one is leaving the train station. This one's coming back to the train station. So we've got our nice solution here. All right, at what time are the two trains at the same distance from the city? How many hours after they left? 6 hours. And how far away were they?
300 miles.
300 miles. So my solution would be 300. All right, go ahead and answer 1, 2, and 3 by yourself. Yes. So it's going to be hours. So hours, and then for number 3, they'd be miles away from each other. Yep, great question. All right. Hopefully you got before and after 6 hours. And then who can tell me how far are the trains from each other at 4 hours? Jackson?
250 miles.
Yep. Train A is at 450 miles. And train B was at 200. So 250 miles apart. Okay, do you guys want to try flying birds with a partner?
Yes.
Just try it.
No,
Just
please be done. Please.
I just want to create the equations, and then we'll be done. I promise. Create the equations, and then we'll move on. You can do it. You can do it.
Would it be a negative? Because it's descending.
Good job.
What do you like? Which option is your favorite and why? Is it easy? Yeah. And then somebody would usually for breakfast and they usually get for breakfast and then like what food would you not eat?
You want us to actually do the problem?
You can start it if you want to. I'm just curious what you guys are going to come up with.
I did the equation. Is that all I have to do?
Can you check it?
Yep. Come in. I think there's a typo, but it doesn't seem to have affected any of your equations. The last sentence I don't think is correct. So bird A is 500 feet in descending. Bird B is originally 100 feet in ascending. And then it says bird A is ascending, which is not, this should be B and then A, right? It's okay. Go ahead and just like cross this out. So you should have had y equals negative 75x plus 500. And y equals 25x plus 100. How'd we do?
Good.
Awesome?
Yeah.
Okay, we'll stop right there.
Silent.
Nice job, guys.